as we continue on, what does the y-intercept of the best fit line mean in this situation? Well, their y-intercept is there. Remember, the y-intercept is always when x is 0. Now, the y-intercept in the table is different from that of the best fit line, but this is asking about the best fit line. So there's our y-intercept. And what it means is that we predict that, well, when x is 0, that means it's the year since 1996. That means we're talking about the year 1996. That in 1996, 151,595.11 cars were sold. And remember, we say it's a prediction because this is the best fit line. Find the slope. So slope, remember we talked about a lot of different ways to think about slope. Change in y over change in x, rise over run. When we look here, because it's a graph, I like to use rise over run. So I find these 2 points. And really, you could have a bunch of these points that I can find the coordinates relatively easily because they are in the intersection of grid lines. And I see that I go down 1, right 2, down 1, right 2. So my rise is a -1 because I'm going down 1. My run is a +2. So we get a slope of -1/2, which makes sense because we have a decreasing function. Over here, I'm given 2 points. We talked about 2 different ways to do this. We could make a table. X and y, you have -4 and 6, -4 and 10. So as I do that, we see that y is increasing by 4 as x increases by 0, which means our slope would be 4 divided by 0. But if you punch that in a calculator, to simplify, what we see is 4 divided by 0, it says there's an error because you can't divide by 0. So what that means is that the slope is undefined. Another way you could have done this is to use the slope formula. Slope is the y2 minus y1 over x2 minus x1, which would be 4 over 0 again, which is still undefined. And I think it's helpful for us to look at a graph for this one. So if you do a quick sketch of a graph, -4, 6 would be like maybe here, -4, 10 would be up here. And what you notice is that you have a vertical line. And there's a vertical line. The slope will be undefined. Question now number 4 asks to find the x and y intercepts. Our x-intercepts are where the graph crosses the x-axis. So here's our x. We have 1, 2, 3, 4 x-intercepts. So your x-intercepts, it looks like, are going to be -7, 0, -3, 0, 2, 0, and 4, 0, all 4 of those points. The y-intercept is where the graph crosses the y-axis. So we have this point right here, which looks like it's 0, 1, 2, 3, 4, 5. So 0, 5. For B, we're given an equation. There's a couple different ways to do this. So one way is to look at your graphing calculator. If I go to y equals in my calculator, I can, where do we go? Y equals, there we go, I can enter this in, -9x plus 30. I can go to the table. Oh, there's the graph. Okay, so we see that it has 2x, or y-intercept and an x-intercept. It's kind of hard to see what they are. So I'm going to go to the table. And I know that my x-intercept is when y is 0. My y-intercept is when x is 0. So first let's find where x is 0. X is 0 and y is 30, which also makes sense because when you look at the equation that has a y-intercept of 30, it's in slope-intercept form, so that would be 0, 30. So then we have to figure out when y is 0. Well, we're positive here, so if we go down, 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 we're getting closer. But now we see we go from 3 to -6. Well, if we go from 3 to -6, we know somewhere we hit 0 in between there. So our x-intercept is somewhere between 3 and 4. But it's not going to be directly in the middle because 3 is actually closer, or sorry, 0 is closer to 3 than it is to -6. So there's another way to do this. Another way to do this is to look at our equation and realize that the y-coordinate will have to be 0, so I could put 0 in for y, and then solve for x. I can do that by subtracting 3 from both sides. I get -30 is equal to -9x. Divide by -9, I get that this would be a positive 10/3, or that would be 3 1/3. if we made it into a mixed number, which makes sense because that was between the 3 and 4 like we talked about. Now you could have used the equation as well for the y-intercept. We would just make the x 0, so y equals negative 9 times 0 plus 30. And what we see is, then you have 0 plus 30, which is just y equals 30. And there's our answer. Look into the back. For number 5a, it says write an equation of the line containing these 2 points. Alright, so when we look at that, writing the equation of the line, well, often we need the slope in order to write the equation of the line. So if I have 2 points, I can find the slope. I'll do the change in y over the change in x, and I get 0 over 10. And I know 0 divided by 10 is 0. I can test that again if I can't remember. Put that in my calculator. 0 divided by 10 tells me it's 0. So the slope is 0. Now from there, I could use point slope form if I wanted to. Y minus y1 equals the slope times x minus x1. And then what I see, though, is that 0 times that just ends up being 0. So when I add 9, I get y equals 9. And there's my final answer. But there's other ways you could have done this. So let's just think through what this means. Like if I looked at a table, x and y, and I had, well, that would be higher up there. So let's negative 6, comma 9, and then I have 4, 9. And notice from here to here, we're not changing it all. From here to here, we're adding 10. But if we're not changing, that means all of these guys are 9, which means no matter what the x is, the y has to be 9. So somewhere in here, we'll have like negative 5, negative 4, we'll have 0, 1, 2, 3. So our y-intercept will be 9. Our slope is 0. So you still get this, if you thought of slope-intercept form, y equals 0x plus 9, or y equals 9. And the other thing I want to make sure we do is think about this graph. If the y-coordinate stays the same, if you recognize that right away, we can see, well, 4, comma 9 would be here. Negative 6, comma 9 would still have that same height. We'd be going up the same amount, which makes this a horizontal line. And we can see that, well, if that's at 9, that y-intercept would also be 0, comma 9. So you have a horizontal line, so that means the slope is 0, and then it must have a y-intercept of 9. So y equals 9. So a few different ways to think through that problem. For 5b, write an equation of the line represented by the table. Okay, so when we look at this, I'm going to try and find the rate of change. So I'm adding 1 each time to the y-coordinate. The x-coordinates are adding 2 each time. So that tells me that my slope would be 1/2. Then I also know I need to find the y-intercept. Now, a lot of times we think of the y-intercept as just where we see the 0. So sometimes we might be inclined to look and see 0 here, so say the y-intercept is 4. However, it's when x is 0. So I got to work backwards in my table. So as I work backwards, minus 2, that would be a 2. Minus 1, that would be negative 1. Minus 2 again would be 0. Minus 1 again would be negative 2. So there is my y-intercept. So now I can write the equation y equals 1/2 x minus 2. So could you now just ask me to graph this function? There's a couple different ways we talked about graphing. This equation is in standard form, so I have 2 options that we've really discussed. One is to find the x and y intercepts. So if I found the x-intercept, that would be letting y equals 0. So 3x minus 6 times 0 equals 12. That would just be 3x equals 12, and I divide by 3, I get x equals 4. So I'd plot the point 1, 2, 3, 4, comma 0. I could also find the y-intercept by making x 0, so 3 times 0 minus 6y equals 12. Well, that just ends up being negative 6y equals 12, and when I divide by negative 6, I get y equals negative 2, so 0, negative 2. So there you go, and now I could connect those points, draw the line, and I could be done. But I do want to show another way that students often like to do this, and is if I recognize this is not in slope-intercept form, I could get this in slope-intercept form. So I subtract 3x from both sides, and then I have to divide by negative 6, and I have to divide everything by negative 6. So I get y equals negative 3 over negative 6 is a positive 1/2. 12 over negative 6 is a negative 2. And now I have the equation in slope-intercept form. So my y-intercept is negative 2, so I go down 2. My slope is 1/2. I rise 1, run 2, y rise 1, run 2. And look, I get that x-intercept that I had gotten algebraically over here. Then down 1, left 2, down 1, left 2. And now I can graph this line. All right, looking over here, write an equation on the line that is perpendicular to this line. Well, let's think about what perpendicular means. Perpendicular means that they form a right angle, and it also then means that our slopes are opposite reciprocals of one another. So if this slope is 3/4, then the slope of the line perpendicular would have to be the opposite reciprocal, -4/3. Now this just wants any equation, so it doesn't matter what the equation is as long as I have a slope of -4/3. So there's a lot of different possibilities. I could just write y equals -4/3 x. I could write y equals -4/3 x plus 9. Y equals -4/3 x. It could have the same y-intercept. Doesn't matter really what the y-intercept is as long as the slopes are opposite reciprocals. So these are all options. As long as your slope is -4/3, you're good to go. Switching down to number 8, determine whether the relation is a function. So I see these points right here, and I'm thinking, well, a function is a relation is a function if every input has exactly one output. So when I look at this, I can look at these points, and I can say, well, that would be the point 4, 5. This is the point 4, 1. This is 2, 2. This is 2, 4. And then we have 0, 3. A lot of us like to make this into a table, so if you wanted to, you can make this into a table, and we would have, let's just start with here, we would have 4 and 5, 2 and 4, 0 and 3, 2 and 2, 4 and 1. And what we can see is the input of 4 has 2 different outputs, the input of 2 has 2 different outputs, so this is not a function because you have inputs that have multiple outputs. We also talked about another one of these, or another test, and that was a vertical line test. So if you see, I can draw this vertical line, and it passes through 2 points. And it does that because the input of 4 has 2 different outputs. Because this is not a function, we do not have to worry about the domain and range. Number 9 says, is the function modeled by the equation linear? Well, linear equations would not have an x squared, so no, this is not linear because the equation has an x squared term. If you got rid of that and it's just y equals -x plus 3, then we'd be good to go. Because you now it says solve the system of equations. Remember, systems, the solution to a system would be an ordered pair, x, y. When we're solving systems, we can do it by graphing, substitution, or elimination. I'm looking at this and I'm thinking substitution will be easiest because we already have one of the variables solved for. So y equals this, so I just substitute in for y in the other equation. I need to make sure I have parentheses around there. So I need to distribute that -5x minus 5x minus 10. Again, you can think of that as like a -1 equals 20. I have x terms on the same side. 5x minus 5x is 0. So I'm left with -10 equals 20. So my variables are gone, and I have a false statement. This is not true. -10 is not equal to 20. When this happens, we recognize that we have no solution. And if you were to get both of these in slope-intercept form and graph them, these would be parallel lines. And that is it for review number 3.